Alright, so we just covered permutations, and now we need to move on to combinations. Now, the interesting thing about combinations is that they deal just like sets do, where the order does not matter. In permutations, the order mattered. That's the difference between permutations and combinations. So when you say how many ways, or in this case, how many different subsets can we make from a set ABC with just two elements, it's a little bit different because it's not the case that, oh, we have 3 ways to pick the first one and 2 ways to pick the second one. Because if the order is switched, it doesn't necessarily make a difference. For instance, in a permutation, the order ABC and ACB are different. So this is 2. But in a combination, if we have ABC, it is going to be equal to ACB. They are the same thing. So now that we've dealt with the differences here, how many different ways can we make a subset with just 2 of the elements? Well, let's just list them all. So we can have A and B together, we can have A and C together, we can have B and C together, so these are 3 different ways. Now you're saying, well, what about BA, what about CA, and what about CB? Well, these map to ones we've already done, so we simply don't count these. So what we say is that there's 3 different combinations we can make. So here's a nice formula for it. If we have 2 numbers n and k, then we say that n choose k is the amount of subsets that can be made using k elements in an n element set. So this is written as n choose k. Sometimes you see it as a capital C with n bracket or n comma k, just like permutations. And we see the formula here is n factorial over k factorial times n minus k factorial, which you'll see is actually just the permutation function divided by k factorial, which is the number of elements we're making. So in the previous example, you saw 3 choose 2, because we wanted 2 element combinations out of a 3 total set. So with this formula, this is going to be 3 factorial over k is going to be 2 factorial, and n minus k is going to be 1 factorial, which is going to just be 3. So this works. Unfortunately, the amount of permutations there are would also actually the amount of permutations would be 6, so there is a bit of a difference there. Anyhow, let's do some quick practice with the formula here. So when we have 9 choose 4, we will get 9 factorial on the top, then we'll get k, which is 4 factorial, times 9 minus 4, which is 5 factorial. Essentially, if I were to break it up, it's n factorial over some number a factorial plus b factorial, where a plus b is equal to n. If that makes any sense. I think it should, and it shouldn't be plus, it should be multiplied, but you'll see that the 2 bottom numbers equal the top number. If you're confused about what the formula is or what numbers you should be multiplying together as factorials, the 2 bottom numbers, if you add them, should equal the top. So what we have here is we're going to have 9 times 8 times 7 times 6 times 5 factorial over 4 factorial times 5 factorial. You always want to cancel the largest factorial, so that way you're doing the least amount of computational work. So then we're going to get 9 times 7 times 8 times 6 over 4 times 3 times 2 times 1. Now we can simplify things We see that 4 times 2 is equal to 8, so we can cancel out the 4, the 2, and the 8, since that's the same thing as 8 divided by 8. And we can take the 9 and the 3, and we can simplify this. So we're going to get 3 times 7 times 6, which is a little bit more manageable, because that's 3 times 42, and that's just 126. So 9 choose 4 is 126. What about 6 choose 3? Well, this is 6 factorial over 3 factorial times 3 factorial. So this is going to be 6 times 5 times 4. So we're going to cancel one of the 3 factorials on the bottom. Then we'll expand the last one. So of course when we shorten this, we're going to turn the 6 and the 3 into a 2. So 2 times 5 times, and then 4 divided by 2 is 2. So this is going to be 4 times 5, which is just 20. Now these calculations will take a bit of practice to get used to. Of course there's a lot of expansions going on, but it's really just a test of your multiplication skills and if you can remember the formula. If you have a calculator, graphing calculators, you can even have a function. It's a built-in function that does permutations and combinations, so you just plug in the numbers and it solves it for you. If you have access to that, great. But your questions are going to be probably a little bit harder. Anyways, let's do a couple application questions. How many 5-card hands can be drawn from a deck of 52 cards? Now, your first question is this a permutation question or is it a combination question? And you have to know a little bit about cards to know whether or not this is a permutation or combination. When I have 5 cards in my hand, I can reorder them however I want, and it's never going to change the gameplay. Therefore, this is a combination question. So we have 52 total cards, and we want to choose 5. This is our answer, technically. Sometimes you will not have to solve this. Some professors will want you to solve this. Most on exams will say, do not solve this, leave this as your answer, which is fine. But for the sake of completion and explaining the formula, I will write this out. So this will be 52 factorial over 47 factorial times 5 factorial, which will be 52 times 51 times 50 times 49 times 48, all over 5 times 4 times 3 times 2. And you can see why I didn't necessarily want to expand this, because this is getting a little bit crazy. However, we can simplify. We can do 2 into 52, so this will be 26 after we simplify the first two. Then we can do 51 divided by 3 is 17, 50 divided by 5 is 10, 48 divided by 4 is 12, and then we have this ridiculous 49. Now, of course, I still don't want to do this by hand, so we'll leave the answer like that, and that's basically the best you can simplify it without a calculator, unless you're really, really crazy and want to somehow figure out what 490 times 12 is, then multiply that by 17, then 26. So, I don't think anyone wants to do that. We'll leave it at that. Now here's a better question. How many ways can we draw 3 diamonds and 2 clubs? Well, this is a little bit more interesting. Because when we just draw 5 cards, we can do it really however we want. We just say, oh, there's 52 total cards, and then we draw 5, and it's not too bad. However, there are a couple things we need to know. First of all, is how many diamonds are there in the deck, and what is the number of clubs in the deck? Well, there's 13 of each suit, so there's going to be 13 diamonds and 13 clubs, and we just want to draw 3 diamonds and 2 clubs, and it doesn't matter what order we draw them in. So we say, okay, 3 diamonds, that means we have 13 ones we can choose from, and we just want to choose 3. So this is the diamonds. And then we multiply that by the 13 choose 2 clubs. And this will get you your answer. So basically your answer is going to be 13 choose 3 times 13 choose 2. And I'm going to mention right off the bat, this is not the same as 13 choose 5. That is not the same. This is not how combination multiplication works. So do not make this mistake. There is a very interesting way, which I'm going to show you in a second, how we can do addition with combinations. But that's about as far as you can go without proving some really weird and difficult theorems, which hopefully you'll get to do in your course. But first, one more question. What are the odds of winning a lottery where all 6 numbers chosen out of 49 must be picked to win? Now, this is a little bit different because I'm asking for the odds. And when I say the odds, I mean the situation that it occurs in. So the number of situations where you win divided by the number of total situations. Okay. So what's interesting is that if we can only pick 6 numbers and all of them have to be chosen, then there's only going to be one situation where we can win. But how many total ways are there to do this? Well, we just have to choose 6 numbers out of 49. So we're going to have 49 choose 6 on the bottom. And this is your answer. And you have to be very careful because we talk about the odds. So it's the number of ways you can win over the number of total situations you can do it. So we have 1 over 49 choose 6 because, of course, there's 49 numbers in the lottery and you have to pick 6. And if you know anything about lottery tickets, when you have your ticket here, it'll say something like Lotto Max at the top, and it'll list your numbers in chronological order at the bottom here. So the order doesn't matter because it's going to be listed chronologically anyway. If the permutation had to be perfect, there would be a lot less winners. In fact, in this scenario, if the permutation mattered, there would be 6 factorial. Well, your chance would decrease, your chance would decrease by a magnitude of 6 factorial if this were the case where permutation was important. Now, given the word Tallahassee, so this is a little bit interesting, because we're going to combine something we learned in permutations and combinations. How many ways, or how many arrangements, can be made with this word where there's no consecutive vowels? This is an interesting problem. So we're going to do what we did before, and we're going to list all the letters out. We're going to stack them so we know how many of each letter there are. Tallahassee. So, okay. We have 3 A's, 2 L's, 2 S's, and 2 E's. Of course, we have lots of these, otherwise I wouldn't have picked this question. Now, how many arrangements can be made with no consecutive vowels? So, a strategy here is saying, let's leave the vowels out for now. Let's look at those later. So now we have a word that is TLLHSS. And we ask ourselves, how many ways can we arrange this word? Well, this should be fairly simple. We see there's 6 total letters, so that's 6 factorial. We have 2 L's, so we divide by 2 factorial. We have 2 S's, so we divide by 2 factorial, because they are indistinguishable from each other. So here's the first part. We're going to have to multiply this by something, but how do we figure out what to do with the vowels here? Well, remember that order does not matter. So, where can we place the vowels here? We can place one before the T, between the T and the L, between the L and the L, L and the H, HS, SS, and right after the S. So there's 1, 2, 3, 4, 5, 6. There's 7 positions we can choose to put the vowels. So that's 7. And there's 5 vowels, so we have to choose 5. Okay, so now we've chosen 5 out of 7 positions. Now there's still one more step to the puzzle. And now we have A, 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 E, E. Well, we still have to order these ones too, because there's different arrangements. So there's going to be 5 factorial of these vowels over 3 factorial times 2 factorial. So we then have to multiply it by 5 factorial over 3 factorial by 2 factorial. So this question got really messy, and conceptually, it seems like a very easy problem. And it sort of is, but wondering, oh, where do I start to break it down? Where do I go next? This is the difficult part. So when you say, okay, I don't want this group of things to be together, you separate them from the group, you figure out the number of arrangements of the rest of the things, you figure out the number of arrangement of the things you're trying to keep separate, and then you just see how many spots you can put those other things into them, and then you choose the amount that you need. So in this case, we listed out all the letters. We said, okay, we want the vowels separated, so let's figure out how many ways we can assort the consonants. Let's see the amount of spaces we have for the vowels to put into after we have arranged our consonants. And then how many ways can we arrange those vowels before we put them into the different positions. So anyways, that was some introduction to combinations. We get to see some cool things we can do with combinations and how they relate to this very cool structure called Pascal's triangle in the following video, which I think is a lot cooler than this stuff here. If you find mathematics and combinations cool, which I hope if you're watching a video 17 minutes in on YouTube on your spare time, you do find mathematics a little bit cool. If not, I don't know why you're taking the course or why you're watching it, but I mean, if it's for me and you love my voice, thanks a lot, but you're kind of weird. I'm just kidding. Anyways, if you have any questions, as always, leave them in the comments and I'll get to them as quickly as I can.